So my dear friends, we are doing AP and GP. So maximum points, all the points in AP, I hope we have completed. There is no point in AP it's pending. Let me check once if any point is pending. This one, 7th point. 3 terms in AP, like 3 terms in GP, what we have taken A by R, A and AR. The same way here, A minus D, A and A plus D. 4 terms are there, A minus 3D, A minus D, A plus D and A plus 3D. See what I have written here, do option verification. Okay, means in very rare cases you will apply this formula. In maximum cases we will be doing option verification itself. So you need not worry about that. Next, nth term from the end. Like we are having nth term from the end in GP. Here also we have nth term from the end in AP. L plus n minus 1 into minus D. You are coming from, see if you are going forward, you will add D. You are coming backwards, you will subtract D. Okay. So that's the reason L plus n minus 1 into minus D. We need not remember that, but just before the examination, once revise it and that would be enough. Next, all the sums from ICM material I have solved. There's no sum pending. So here also everything we have covered regarding infinity, everything. Yeah, all the points we have covered. Yeah, this one, point number 15. If one arithmetic mean and 2 geometric means are to be inserted between 2 numbers, then G1 cube plus G2 cube is equals to 2A G1 G2. So basically, this is the rule what you will be using over here. However, it's not important for the examination. Once I guess in 2003 he asked. After that, he never asked this point. So if you can remember it, or else you can leave it. Next. Now, see this one, it's an important point. If progressions are given and value of equations are asked, just to take their coefficients is telling. Sir, what is this just to take their coefficients? Let me take out the question. Give me 1 minute. I have to open this material before the class itself every day. Yeah, see here. See this example. I am telling A, B, C are in AP. Okay. Then he is asking the value A square plus 4AC plus C square whole divided by AB plus BC plus CA. Or one more question he is asking A cube plus 4B cube plus C cube whole divided by B into A square plus C square. This is the question what he is asking. He is telling A, B, C are in AP. Not only in AP, they can be in GP also. Let him give any progression. Okay. Like see here what he is telling. He is telling if progressions are given and values of the equations are being asked, just to take their coefficients. So here also what I will do, progressions are given, value of equations are asked. So I'll just take the coefficient. Now see here how will I solve it by taking the coefficient. What is the coefficient of A square? Obviously nothing is there, so 1. AC 4, C square 1. AB 1, BC 1, CA 1. So 6 divided by 3, which is equals to 2. Next, here 1 plus 4 plus 1. Coefficient of A cube 1, coefficient of B cube 4, coefficient of C cube 1. Divided by B is 1, A square is 1, C square is 1. So 6 by 2, which is equals to 3. Okay, this is how you will solve the sums. If an progression is given and an equation is given, this is how you take those equations. You will see ABC and AP, you can even substitute 1, 2, 3 also. There is no headache over there. Only thing is that it's going to become a little lengthy. That's it. Okay. Next. I'm telling if sum is given and term is asked, or vice versa, go ahead and do option verification by remembering T1 is equals to S1 S2 is equals to T1 plus T2. Okay. Now what he's telling? He's telling sum is given and term is asked or vice versa. He's telling go ahead and do option verification by remembering T1 is equals to S1 and S2 is equals to T1 plus T2. That's a given one. Now see here how will we solve it. Example. Yeah, fine, perfect. Now see here, say for example, I am telling 1 plus 2, 1 plus 2 plus 3, so on. This is the progression. Okay. He is asking you to calculate sum of n terms. What's happening to this again? 1 minute. Let me check this connectivity. Okay, see here. I'm having a progression which says first term is 1, T1 is 1, T2 is 1 plus 2, T3 is 1 plus 3, so on. He is asking you to calculate sum till n terms. Either you can normally solve this, okay, or else you can go ahead and you can do option verification. Now see here, how will I do option verification? First option what I have is n by 3 into n plus 1 into n minus 2. Second option what I have is n by 3 into n plus 1 into n plus 2. Third option what I have is n into n plus 1 into n plus 2. Option D is none. Now my dear friends, we already know that T1 and S1 both will remain same. Okay, he gave you terms. This is first term, this is second term, this is third term, so on. He is asking you to calculate sum till n terms. Now we know T1 and S1 is same. What is T1? 1. Now in all the three options, I'll substitute n is equals to 1 and I'll shift. 1 by 3 into 1 plus 1 into 1 minus 2. 1 by 2, 1 by 3 into 2 minus 1. So it will be minus 2 by 3. That is minus 0.666. What is T1? 1. What is S1? Minus 0.66. So option A is not correct. Now let's check in option B. 1 by 3 into 1 plus 1 into 1 plus 2. 1 by 3 into 1 plus 1 is 2. 1 plus 2 is 3. Cancel. This is going to be 2. Next, let us check here. Obviously, 1 into 1 plus 1 into 1 plus 2. 1 into 2 into 3, which is equals to 6. So in all the three cases, I hope it is not satisfying. Let me check what option we have. 57. Yeah, 57. Answer is D, none. Okay. In this question, we are having answer as none. Sir, answer is none. Okay, we understand. But can you please tell us how to calculate the answer without option verification? Yes, I can tell you. This is a simple question. Okay. Now, how will you calculate sum of first n terms? N by 2 into first term plus last term. Right? N by 2 into what is first term? 1. What is last term? 1 plus 2 plus 3 plus 4 plus 5 plus so on till n terms, right? See, in this question it is simple, so I am solving. n by 2 into first term is 1. What is 1 plus 2 plus 3 plus 4 plus so on till n term? Sum of first and natural numbers n into n plus 1 whole divided by, that's how I'll say. Okay, you want to take LCM? Let's take LCM. N by 2 into, what is LCM? 2 plus n into n plus 1 whole divided by 2. So 4 2n plus n square into n plus 1 whole divided by 4. This is the answer. This is Sn formula. 2n plus n square into n plus 1 by 4. So now question asks, sir, how will you apply Sn is equals to arithmetic progression? Okay, it's not in terms of arithmetic progression. Okay, see, only in this case this formula is applicable. Okay, this is just like a random formula I've applied. Basically, this formula will not be applicable. Only in this case it will be correct. That's the reason I use the method of option verification. Okay, this is the only question where this formula goes correct. In any other question you apply this formula, answer will be wrong. Okay, so this is basically a coincidence, I can say. Okay, but this is the only question where I have seen that this answer is getting correct. And rest out nowhere this answer gets correct. This way of solving. You can ask, how can you use Sn as arithmetic progression formula? See, you can't use, that's wrong. Only in this question it's working, so I have used. Okay, so best method is option verification only. Now, see here, solve this sum and tell me the answer. Use option verification, solve it and tell me example. I'm having 1 square plus 3 square plus 5 square, so on. Calculate sum till n terms. Okay, odd number square he is asking. Option A is n by 3 into 4n square minus 1. Option B, n square into 2n square plus 1. Option C, n into 2n minus 1. Option D, n into 2n plus 1. Now, what is term 1? Term 1 is 1 square, which is equals to 1. Now, in 4 options, substitute n is equals to 1 and tell me where you are getting S1 as 1. S1 you have to get it as 1. So where you are getting, please do let me know. Is it in option A or option B or option C or option D? So Vaishnavi, you are saying option A. Option A and option C both are matching. Let's check. Option A, 1 by 3 into 4 into 1 square minus 1. 1 by 3 into 4 minus 1, which is equals to 1. Option A is matching. Option B will not match. 1 square into 2 plus 1, which is 3. Option D will not match. 1 into 2 plus 1, which is 3. So 1 into 2 minus 1, which is equals to 1. So option A and option C both are matching, sir. Then in this case, how will I solve? I'll go ahead and I'll substitute n is equals to 2. Let me substitute n is equals to 2. N is equals to 2. 2 by 3 into 4 into 2 square minus 1. 2 by 3. 2 square 4. 4 into 4 16. 16 minus 1 is 15. 3 ones, 3 5s. 10. Here 2 into 2 minus 1. 2 into 4 minus 1, which is 6. But what is S2, my dear friends? S2 will be equals to T1 plus T2, right? 1 square is 1, 3 square is 9. What is 1 plus 9? 10. So which option is satisfying 10? Option A is satisfying. So Sn, see here, progression is given. T1, T2, T3 is given. Is asking you to calculate Sn. If you substitute n is equals to 1, you will get S1. If you substitute n is equals to 2, you will get S2. If you substitute n is equals to 3, you will get S3. What is S1? S1 and T1 is same. What is S2? T1 plus T2. What is S3? T1 plus T2 plus T3. Okay. I hope it is clear. Yes, sir. If you want in option A, instead of n, you substitute 3. And see what happens. You will get 35. 1 square 1, 3 square 9, 5 square 25. 25 plus 9 plus 1, 35. Option A will satisfy. That's how you will do option verification if terms and sum is given. Okay. Very rarely they'll ask in the examination, but still we can't take a chance for this. I hope that's fine. Now let's proceed to the next one. So three of you, is this point clear? S1, T1, how to identify? Now this sum I have done, right? One last sum you do, and then we will close this concept. I'll go for two more sums are there. Then we can go for the next concept discussion. Just solve this and tell me. Example. A, B, C are in GP. Then tell me A square plus B square, AB plus BC, B square plus C square are in what progression? Next example. You can solve this till that time. One point four plus 3.7 plus 5.1, so on. This is progression. Find SM. Option A, n by 3 into 4n square plus 5n plus 5. Option B, n by 2 into 5n square plus 4n minus 1. Okay, dude, I'll look into that. Option C, n by 2 into 4n square plus 5n plus 1. Option D, none. My dear friends, remember in progressions, if he's telling 1.4, 3.7 and 5.10, it means it is 1 into 4. Here point is read as into in progressions. 3.7 means 3 into 7. 5.10 means 5 into 10. Be careful. Solve these two questions and tell me the answer. I'll wait for 2 minutes. See here. A, B, C and GP. GP means 1, 2, 4. Okay. Let's substitute. 1 square plus 2 square. 1 into 2 plus 2 into 4. 2 square plus 4 square. 1 square is 1, 2 square is 4, 5. 2 plus 8, 10. 2 square 4, 4 square 16, 20. So 5, 20, 10 and 20. It is clearly evident that they are in geometric progression. 5 into 2, 10, 10 into 2, 20. Next example. Let us substitute n is equals to 1. And let's see what we will get. 1 by 3 into 4 plus 5 plus 5. 5, 10, 14. 14 by 3. But I want to get 1 into 4, which is 4. Option A is gone. Option B. 1 by 2 into 5 plus 4 minus 1. 9 minus 1, 8. 8 by 2, 4. Option B is satisfying. Let's check option C also. 1 by 2 into 4 plus 5 plus 1. 5 plus 4, 9. 9 plus 1, 10. 10 by 2, 5. So option C is not satisfying. What is satisfying? Only option B is satisfying. Okay. So I hope all these questions are clear. Yes, sir. All these questions are fine. Okay. So that's it regarding GP. The next important question which I need to find. Please do that homework questions. What I have given yesterday and day before yesterday. I hope by now index number should have been done. Now division sums are there in your material. Those are not that important. But yeah, one sum I'll tell you. Example, not that important, but let me give you one sum. 2 power 4n minus 1 is divisible by 2 power 4n minus 1 is divisible by what number? Let's check. Option A 15, option B 4, option C 6, option D 64. Now, whenever such type of numbers are given, again go ahead and substitute n is equals to 1. 2 power 4 minus 1. 2 power 4, 16 minus 1, 15. Which among 4, which is matching? Option A is matching. If you want, you can check n is equals to 2 also. 2 power 8 minus 1. 2 power 8. I hope 2 power 8 is 5 to 1. Let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Minus 1. Which is 5, 11. 2 power 4 n minus 1. This is not minus 1, this is minus n. Sorry. 2 power 4 n minus n. Now, so this will be 510. Again, 510 is also divisible by 15. So what is the answer? Option A, 15 is the answer. Okay. So whenever he is telling divisible by any number, just substitute n is equals to 1, n is equals to 2. Which satisfies both the things, that's going to be the answer. Okay. So that's all regarding AP and GP. So we are done with AP and GP. We are done with central tendency and dispersion, index numbers, AP and GP. Okay. And we have completed one part of introduction to statistics. 2 parts of introduction to statistics are still pending. We have to do that. 1 minute. I'll share this notes immediately after the class. If I don't share, please do remind me once. If I forget. Let us go ahead and let's start with probability now. So not probability, permutations and combinations. What I'm doing. And please make sure this week you will complete that time value of money also, because our target by the end of the week is to complete 25 plus 25, 50 marks. What permutations and combinations. So basically this permutations and combinations, here we will see how many possibilities are there for a given word or a given system. So before starting with permutations and combinations, there are two things what you need to learn. You need to learn addition rule, multiplication, addition and multiplication rule, and factorial. Okay. Now, first let us start with addition rule, addition and multiplication. Now, what is this addition and multiplication rule? It's quite simple. Whenever two or more statements are connected with a word or, when two or more statements are connected with a word or, you will do plus. Two or more statements are connected with a word and, you will do into. That is your multiplication and addition rule. Like say for example, I am telling a person has 5 shirts, 4 pants. In how many ways he can go to a function? Okay, I'm asking how many ways he can go for a party. You'll wear shirt and pant, or you'll wear shirt or pant. Obviously, sir, any human being will wear shirt and pant if he is in census. Now, how many shirts this fellow has? 5. What is the connecting word? And pant 4. So that 20 ways for him to go to. A person can go from A to B in 9 ways. First question, in how many ways he can go from A to B and return in different way? Second, A to B and return, not return, sir, it is return and return What return in same way. A to B in a 9 ways. Sir, what are these 9 ways? There are 9 routes for him to go from A to B. Okay. From school to college, you can go in shortest route. You can go in longest route. You can go in medium route. While going, we always select longest route. While coming back, we always select shortest route. Like that. While going, I'm having 3 routes. While coming, I'm having 3 routes. But you people have only 1 route. To go longest route, to come shortest route. Okay. See, I'm telling a person can go from A to B in 9 ways. A to B in 9 ways. Connecting word is and, into. Return in a different way. You're not that you saw some beautiful thing in one place. While coming back, you want to see the same beautiful thing again. So you'll come only in that route. There is no selection, there's no confusion now. You saw something beautiful in that way, you will come only in that way. 9 ways. How many ways he can go from A to B? 9 ways. And coming back, he can come in any way, 81 ways. So this is how you will be using addition and multiplication rule, my dear friends. If they are connected with the word and, you will be using multiplication rule. The connected word is or, you will be using addition rule. Like say for example, to go from school, it will take you back in cycle. So what is the connecting word here? Obviously, or I can go either in 5 autos or 4 buses or 1 cycle. The answer is 10 ways. You can't say that, sir, first I'll go in 1 auto. I'll come back. I'll go back in next auto, 3rd auto, 4th auto, 5th auto, 1 bus, 2 bus, 3 bus, 4 bus, 1 cycle. I'll do like this. Then you will be useless person. You're just randomly wasting your time. So if you want to go from school to home, 5 autos, 4 bus and 1 cycle, you're having total 10 ways because connecting word is or. You will select either auto or bus or cycle. You can't select all the 3. I can't use the connecting word and here. Okay. So I hope the concept is simple. Yes, sir. Let's proceed further. Addition and multiplication. We have some beautiful questions on addition and multiplication. Let me take them out. After this, we will do sets also one day. Sets. In how many ways can 3 rings of a log can combine leading to unsuccessful attempts? In how many ways 3 rings of a log can combine leading to unsuccessful ways? Unsuccessful items? What I wrote there? Attempts I wrote. Okay, sometimes even I get confused. What have I done? That happens for me also. Studying also sometimes I write something, I read it something. Like read threaded is there. I'm reading it as retreated. Later, after reading 2-3 times, I understand it's not retreated, it is rethreaded. Rethreading of tires. It's not retreating the tires. Okay. So in how many ways 3 rings of a log can combine, leading to an unsuccessful attempts? Total 10 numbers are. Okay. Sir, can it start with 0? My dear friend, this is not number, this is not phone number or something. Okay. This is your there is a log. For that number coding system is there. Okay, it can start with 0. Thing can be 0, 0, 0. Nothing is going to happen. So here I can place 10 things, 10 things, and 10 things. I have to combine all the things, right? For combination, what we'll be using and I will be using. So 10Q. He's telling unsuccessful attempts. Obviously, one unsuccessful attempt or one successful attempt will be there. What is that one successful attempt, sir? Correct code, correct pin. So 10 cube minus 1. 9. 2 factorial. 2 multiplied backwards. 2 into 1, 2. 3 factorial. 3 multiplied backwards. 3 into 2 into 1. 4 factorial, 4 into 3 into 2, 24. 5 factorial, 5 into 4 into 3 into 2 into 1, 120. Next 6 factorial, 720. 7 factorial, 5040. This is wrong over here, please correct it. I missed this one. 7 factorial, 8 factorial, 28, 880. Just remember this. You can remember till 7 factorial. It is enough. 8, 10, 9, 5, 8, 9 factorial and 10 factorial need not remember. So what is factorial? Sir, simply n multiplied backwards is called as factorial. N factorial, how will I write? N into n minus 1 into n minus 2, so on till 1. Okay. Or I can even write it as n into n minus 1 factorial. So how did you write it as n into n minus 1 factorial? See here. What is 5 factorial? 5 into 4 into 3 into 2 into 1. Can I write it like this? 5 into 4 factorial. Will anybody stop me? No, sir, nobody will stop you. So n into n factorial can be written as n into n minus 1 factorial. Now, my dear friends, first understand where you will be using permutations, where you will be using combinations. Permutations will be used at a place where arrangements must be done. Means order is important. Combinations is a place where selection will be done. Means order is not important. Like say for example, you are giving prizes. Is the order important? Prize 1, prize 2, prize 3. Which person takes the prize? It impacts the order. That's the reason. I am giving 3 prizes of same amount. 1000 rupees, 1000 rupees, 1000 rupees. Will it impact in which manner you gave them? No. Combination. Now don't worry, question will tell you whether to use permutations or combination 99.99% cases. If they don't give also, you will understand. Whenever there is selection, committee formation, geometrical application, some selecting you do, where order is of not important, their combination. Selection you do where order is important, there you do permutation. Okay, like 3 jobs are there. Job 1 10,000, job 2 8,000, job 3 6,000. Permutations will be used. 3 jobs are there, same salary. Combinations we use. Order is not important. You give in which order, nobody cares. Their combination. You give in an order where everybody cares. No. Number of ways of arranging R things from N things is NPR ways. Okay. Like 3 students are there. I need to make them in 3 places, sit them in 3 places. In first place, any of the 3 people can sit. In second place, any of the 2 people can sit. In first place, this has no opportunity, he'll go and sit here. Now all the 3 must sit, right? So I'll be using and 3 into 2 into 1, that is 6. Or else instead you can say 3 people are there, 3 places are there, 3p3, which is equals to 3 factorial 6. Fine. NPR. How will you write NPR? N factorial by n minus r factorial. Like 9p3 is there. 9 factorial divided by 9 minus 3 factorial, or 9 factorial by 6 factorial. Or else, sir, I'll not take this much headache. I want straight answer. NPR means n multiplied backwards r times. Like 9p2, 9 multiplied backwards 2 times. 9p4, 9 multiplied backwards 4 times. 7p3, 7 multiplied backwards 3 times. Okay, so what is NPR? N multiplied backwards r times. NPR, n multiplied backwards n minus r plus. Like see here, 9 minus 2, 7, 7 plus 1, 8. 9 minus 4, 5, 5 plus 1, 6. 7 minus 4, 4, 4 plus 1, 5. So last number will be n minus r plus 1, or simply you remember n multiplied backwards r times. Okay. Restriction: n should always be greater than or equals to r. This n should always be greater than or equals to r, and it must always be positive. Negative numbers can't come in combinations. Sorry, permutations and combinations. In entire permutations combinations, only positive numbers will come. Okay. Next, what is 7p1? 7 multiplied backwards 1 time. So 7p1 is 7. np1 is 7. What is 9p1? 9. 11p1? 11. 6p1? 6. np2, n multiplied backwards 2 times, n into n minus 1. np3, n multiplied backwards 3 times, n into n minus 1 into n minus 2. Okay. I hope first 2 points are clear, everybody. No. Again, I thought I will continue till 8:30, but due to a medical emergency, again I'm supposed to leave. So today again there's a half an hour delay. So we are in 2 classes delay and we are in half an hour delay. Okay. So tomorrow I'll try to take extra half an hour and complete this permutation. Because tomorrow our target will be to complete permutation. Day after tomorrow our target will be to complete combination. So at Friday we can do some previous year questions. Okay. And Saturday we can deal up with sets. So that's it. I'll share that sequence and series notes. Tomorrow I'll take extra half an hour. Today, due to medical emergency, I need to leave again. So tomorrow I'll take extra half an hour at any cost. But 7 to 9 I may plan. So plan your schedule accordingly. Okay. Or 7:30 to 9:30. Post evening itself. That's it. Balance things we'll see in tomorrow's session. I'll share the sequence and series notes.